So, what is your experience from the chemistry?
Sorry, your voice was breaking. Hello?
Yeah. Can you hear my voice?
Yeah.
Okay. Some basic concepts of chemistry. So, what are your views on chemistry? Do you find it easy or difficult? Tell me.
Some parts are easy, some parts are a little tough,
Yeah,
but mostly it's fun.
exactly. Okay. You need to understand the things around you in detail. Okay. Whatever. Some things are very easily visible. Okay. That can be explained by chemistry. But there are some things which are not visible to a common person, which actually require more keen eyes or maybe some advanced technologies. Okay, that can also be understood by the help of the chemistry, and it is fun, right? Chemistry. Let me start chemistry with the definition. It is branch of science which deals with the study of matter. And matter, what do we study in matter? It's physical properties and chemical properties.
Matter, there are three states of matter.
Yeah, very good.
And
Physical and chemical properties, and the matter, various changes which matter will undergo in various chemical reactions.
yeah, okay.
The various changes. During various physical and chemical processes.
Okay.
Okay.
Yeah.
So this is all about the chemistry. So it is a basic. It is a very short definition. Okay. So, but just a short and precise definition which helps us to understand everything in detail. Okay. And there are how many branches of chemistry are there? Can you tell me? How many branches of chemistry are there? At your
Chemistry, I
level?
think.
Hmm? Actually, there are a lot of branches.
Two. Inorganic and organic, I think.
Yeah, exactly. Actually, these branches get subdivided into various other branches as we move to higher level, research level, and all. Okay,
Yes.
and but as of now, let's keep it very simple, and we divide it into three branches: physical chemistry, physical, and general chemistry.
Okay.
So this is what we will be starting with general chemistry, the calculation part, and the calculation part, it will be useful everywhere. Okay, it will, in all the chapters. Then you have organic chemistry,
Yes.
and you have inorganic chemistry. So physical chemistry is actually what it involves a lot of chemical calculations. Okay, mathematics is involved in doing the calculations. Yeah, so it actually you study various laws.
Yes.
Suppose if you are heating something, what will happen to it?
Uh, if we keep on heating, we reach its melting point or boiling
Yeah,
point if it's a
yeah,
liquid.
it may reach its melting point. It may then it may become liquid. Very good. Then if you heat it further, it may change into gas. Yeah.
Yeah.
So how much heat need to be given? That can be calculated depending upon the mass of the substance which you have taken.
Yes.
Okay. And so you can do the calculation and everything. Okay. So and you can note down how much heat is required to melt it and how much heat is required. You can calculate in joules or kilojoules, right? So all that calculation and laws which govern the change in matter
Yeah.
are studied under physical and general chemistry. Okay.
Okay.
Or sometimes it may also happen that if you heat it, the substance may decompose. It breaks, just like calcium carbonate. Before it depends. So all of this we will study. For example, calcium carbonate is there, and calcium carbonate, if you heat it, what happens? It doesn't melt; it decomposes. Okay,
Yes.
it decomposes to CO, lime, and CO2. Right,
Yeah.
and so whether it decomposes, whether it melts, or sometimes it may burn. It may undergo reaction with oxygen. Sodium, if you heat it, or not only heat it, just if you keep it
Yeah.
in the
Just keep
air,
it in air, it burns, it catches on
yeah, it
fire.
burns. Yeah. So why some substance burns? Why some substance melt? Okay, why some substance decompose? Actually, this is the matter which we are dealing. We need to understand. We need to get into the matter. What are the particles? What are their properties? Okay, what are their electronic configurations and all, and with that we can make out what is actually happening. Okay.
Yeah.
And whenever there is a chemical calculation involved, lot of laws involved. Okay, that part is comes under the physical chemistry. Okay, and then we have organic chemistry, which is very familiar topic. So what is organic chemistry as per you?
Compounds of carbon and compounds of hydrocarbons mainly.
Yeah, carbon, hydrogen, but carbon is a versatile nature. It can not only connect it to hydrogen, it can connect to
Yeah,
oxygen.
and other functional groups.
Yeah. All that group of that specific group of atom is known as function. Yeah, exactly. Yeah. So all this comes under organic chemistry. Means in wide terms we can say study of
Hydrocarbons.
carbon and its compound. Not only hydrocarbon but other compounds also made up of carbon.
But then why is CO2 not considered as organic compound?
Yeah, actually there are some the very good question. Very good question. There are some carbon compound but which actually behave like a salt, or which do not behave like the normal carbon compound. Normal carbon compound, okay, like alkanes are there and all,
Yeah.
so they behave more like inorganic compound.
Okay.
So that's why just for example cyanide is Cn minus, right?
Yeah.
The KCN, so that is a salt actually that contain carbon, but we don't study it in organic chemistry, right? So they are more like inorganic compound, though they have carbon atom. So then so just they are called inorganic. Okay.
Okay.
And main part is hydrocarbon, but there are alcohols also, carboxylic acids also. right? And
Yeah.
what is there in the inorganic chemistry? Tell me.
All compounds that are not part of organic chemistry.
Yeah, yeah. Study of it includes the study of elements, all elements.
Minerals and
Yeah, minerals other than that of carbon. Okay, and their
yeah.
compounds.
Okay.
So inorganic is also a very vast topic. Other than carbon and their compounds. Right? This is all about inorganic chemistry. So actually, it has a very wide application. There are because we need to research new things. Okay, new
Yeah.
substances. So not all the substances are made up of carbon. Suppose if a rocket is you going into the space, you need some material which can withstand huge amount of heat. Okay, so you need some
Yeah.
inorganic substance. There are certain substances like ceramics are there. So ceramics actually in JEE there is a complete separate branch for ceramics. But we as a common person just know ceramics as tiles. Okay, only tiles or
Utensils,
yeah, yeah,
some
yeah. Yeah, tea, the cup and plate in which we saucer in which we take our tea. That's it. That is a use. Okay, that is a common use for a common man. Okay, but in advanced uses in space and in military, there are very important usages. Okay, uh, for ceramics and lot of inorganic substances. Okay, yeah. So that also
yes.
is a very important branch of chemistry. Okay, but it is very wide because today how many elements are there? Tell me.
118.
Yeah, 118 elements, and the last elements are just discovered few years back only. So
Yeah.
just for one element, there is a complete chemistry dedicated only to one element and its compound, that is carbon. But for all the 117 elements, they are studied in inorganic. Okay, so you can imagine how vast it will be, and all their compounds are
Okay.
studied in inorganic. So how vast the inorganic chemistry will be. Okay, so it is very vast, right, and has very high
Yeah.
advanced application, technological applications, okay, in military and space. So let's move ahead. And so it is, let's come down to the simple thing that it was with which we started, that chemistry is the study of matter. Okay, so the first thing which we should get into is the how do you suppose if you are studying the matter, you need to classify it. Okay, you need to know how to classify the basic classification. Yeah, so there is a physical classification which you
Yes.
already mentioned,
And chemical factor.
and
Yeah.
chemical classification. You are in which school?
IAPS.
Okay. There you have CBSE board, right?
Yes.
And chemical classification. So physical classification is just superficial, externally you are going to look. Okay, you are not going to get into the matter, right?
Yeah.
So physical classification means more or less it comes down to states. So how many states of matter are there which are commonly seen around us? Okay. There are two other states also like Bose-Einstein condensate and plasma, but they are not seen in our day-to-day life.
Yeah.
Okay, either at very high temperature or at very low temperature.
Yes.
So this
Yes.
is the physical classification. The chemical classification is actually very important because in order to classify, you need to get into the matter. Okay.
Yeah.
So chemical classification actually. So you can tell me whether the substance is. You can first look whether it is pure. Means only one thing is there, or is it a mixture of two things impure? Okay, a pure thing has a uniform composition.
Okay.
It has a constant composition. What do you understood by this?
That means that the molecules, wherever absorbed throughout the substance, will be same throughout.
Yeah, and the composition is constant. Means suppose if I give you pure distilled water, not seawater, not tap water, okay, they are not pure.
Yeah.
Because they have impurities in them. If I give you some distilled water which is pure, so can you change the composition of the pure water? Can you make it more dilute or more concentrated? Will it be possible for you to make it more dilute or concentrated?
No.
No, because water is water. That's it. You can, but you can change the composition of a seawater, which is impure, because it has a lot of salts into it.
Yeah.
So you can make it more saline by putting more
Yes.
salts. You can increase the density by putting more salts, or you can put more pure water to it to make it dilute, right? So first of all, impure substance have variable composition. And the pure substance will have constant composition. I hope this you understood by heart. Okay.
Yeah.
Yeah. So just take the example of pure distilled water and the seawater, which is right. So constant compositions of pure substance can be classified into
Elements and compounds.
elements and compounds, right? So what are elements?
I can't really explain elements.
Yeah. Elements are actually this pure substance of matter in which there are only one type of atoms. One type of particles. That's it. Only one type of atoms are there. Single type of or single type of atoms are there, but the elements can be monatomic. For example, helium, neon, okay,
Yeah.
krypton, xenon. These are noble gases, right? Radon.
Yes.
They are made up of one atom only. Okay. So helium, if you look, if you get into helium, okay, so you will see only one type of atom, helium atoms. That's it. Okay.
Yes.
So you will see only one capital letter, one type of capital letter in the formula. That is the main thing. Suppose if you have two elements to combine together, those are compounds.
Okay.
It is not a mixture. Someone may argue that it is impure, it is a mixture. How will you protect yourself? How will you convince that it is not a mixture?
Because in compounds, the composition is constant throughout the compound.
Yeah, exactly. The composition is constant, and other thing is that these elements, two or more than two elements, they are chemically associated combined with each other in a fixed ratio, right? It is not a mixture that you put one element, you put
Yes.
another element in the whatever the way you like. That is not there. Okay, they are combining. Okay, so two or more than two elements. Join together, chemically join together in a fixed ratio. So that is a compound. Okay. So
Okay.
for example, water has two atoms of hydrogen one. So you will see two capital letters, at least two capital letters, or maybe three or more capital letters. For example, which is this molecule?
This
Yeah.
is
This is.
C2H2.
You like this molecule very much.
I'm not sure.
This is sugar molecule, cane sugar.
Okay.
N2O2. Okay. So let me. These are elements. Okay. So you can see only one capital letter. One element is there. One type of atoms are there. The particles can be single atom or they can be molecule. If they are molecule, the molecule is a group of atoms.
Yeah.
Only one type of atoms. For example, sulfur is there. Sulfur, the particles, these are the molecules. But molecule doesn't mean that always it will have two types or more types of atoms.
Yes.
If the molecule is made up of only single type of atom, it means what? Okay, it means it is a molecule of an element. Okay, this is the molecule of an element whose atomicity is 8. This is the molecule of an element. This is the molecule of an element. But this one is a molecule of a compound. So compound, the particle of a compound can never be an atom, single atom.
Yeah.
Do you agree with this?
Yes.
Okay. A particle of a compound can never be a single atom because single atom or monoatom. Particle of a compound will always be a molecule because compound will only form when two elements join together. So when the two elements join together, they will form a molecule. So you need to so the particle of a compound is always a molecule, but the particle of element can be an atom, okay, or it can be a molecule. Okay. Right. So elements can be classified further into metals, non-metals,
Metalloids.
metals. Yeah, this is the classification of elements. So compounds can be classified into organic compound, inorganic compound. Okay, that's what we. Or they can be classified into covalent compound, ionic compound. Okay.
Yes.
Yeah, that you can do. Okay, impure substances are mixtures. Okay, mixtures actually are basically mixtures means they have variable composition.
Yeah.
You can add two things as per your requirement, like sugar solution, sugar syrup. You can add the sugar and water as per your requirement, right? Clear?
Yeah.
So mixtures have variable composition, and mixtures can be homogeneous or heterogeneous.
Yes.
So okay. Homogeneous and heterogeneous means what?
Homogeneous mixtures mean that mixtures in which they're complete it's completely transparent and it's a solution basically, like sugar water.
Yeah, very good. So sugar solution means you can't see the components.
Yeah.
Are separated from one another. So homogeneous like sugar solution or salt solution. Once it is prepared, once it is mixed, okay, you can't see the sugar separated. You can't judge by looking that this is the sugar particle and that one is the water molecule.
Yes.
Okay. So homogeneous mixture and heterogeneous mixtures are
Heterogeneous mixtures are mainly opaque and or translucent, and you can like identify the you can differentiate between the particles.
yeah. You can differentiate if you look closely. Okay, you can make out, oh, this is the particle of that substance and that one is the particle of that.
Yes.
Okay. Like if you mix rice and pulses together, you can make out this is the grain of rice, that one is a grain of pulse.
Yeah.
So homogeneous and heterogeneous actually you can make out. So homogeneous are actually true solutions, but it is not necessary that they are transparent. Not necessary,
Okay.
and it is not necessary. Even it is not necessary that they should be liquid only. They can be solid also. Can you give me
How?
can you give me some example of true solution which is a solid and solid?
Solid and solid.
Hmm. But while making the solution, they were melted, but now they are solid.
Alloys, iron and steel.
Yeah,
Iron and
yeah, alloys, brass is
yeah.
there. Yeah, very good. So they are not transparent. So, but once you brass, once it is prepared, you can't make out that this atom is of copper, on that one atom is of zinc. You can't make out. You can't see. It is
Yeah.
just it looks golden colored. Okay, bronze and whatever alloys are there. Okay. Heterogeneous can be of two types.
Colloids and the other one I don't remember.
Yeah, colloids are heterogeneous. So can you give me some example of colloids?
Milk in water
Yeah, milk is colloid, and
and sand in water.
no, sand in water is suspension.
Okay.
That is suspension, and suspensions are the particles are very large and they just settle at the bottom. That's it.
Yeah.
Colloids may appear homogeneous at first glance if you look them from far away. For example, milk may appear homogeneous to you. If a glass of milk is there and if it is kept at a distance, you may find it, oh, this is homogeneous. But if you bring that glass close to your eyes and if you look into it, you may see some droplets of fat.
Okay.
Okay, you can see some fat droplets. Okay,
Yeah.
so you can make out that it is not perfectly homogeneous. It is heterogeneous. Okay, and
Yes.
colloids have lot of colloids are there in our day-to-day life. The common examples are milk. Okay, and the next colloid is our blood. Blood is also a colloid.
Yeah. Okay.
So if you do some if you try to disturb them, suppose milk, what happens if you put some drops of lemon juice, just few drops of lemon juice,
The
can
milk will get curdled and turn into curd,
yeah
yogurt.
yeah 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 all the protein will get coagulated, all the water will get separated.
Yeah.
So these colloids actually they may get separated. Okay. Milk, if you churn, what happens? All the fat comes at the top. So this is
Yes.
a way in which we can see that these colloids work. Even the blood which we give for this test, okay, that blood, if we mix it on the put on the centrifuge, it is rotated and the watery part and the okay and the thick part gets separated. Okay,
Yeah.
suspension are actually very unstable. They don't continue to remain together.
They settle down
Yeah, they
after
settle
time.
down immediately because particles are very large, they are very heavy. Okay, so they can't continue to stay for long. But muddy water sometimes can be colloid if the mud is very fine. Okay. Sand, if you put
Yeah.
sand, yeah, sand, it is suspension. But muddy water is there, so like what we get when it rains, it is yellow in colored. Okay, that's fine particles of clay may not settle immediately. That may lead to colloid formation.
Okay.
Okay, so this is the classification of matter, right? Now the next thing is
Yes.
uh, we need to, because we are working with the matter, we are studying with everything. So we need to actually have some units to calculate. So there will be units of temperature, units of temperature. How many units are there for the temperature?
3 Celsius, Kelvin, and Fahrenheit.
So what is the relationship between
SI
Celsius
unit is
and Fahrenheit?
Celsius and Fahrenheit. 9/5 degrees Celsius plus 30. I can't remember.
Yeah, 5/9 into F minus 32. So 5 and F, you can remember that together. Both start from F, 5 and F minus 32. Okay.
Uh,
Okay. And what is the relation? So what is Kelvin?
Kelvin is the SI unit.
No, it is a standard unit and it is the absolute scale. Okay. Means who
Okay.
decides? Suppose if you are decreasing the temperature, it may keep on decreasing. Okay, but there should be some scale which will tell you that this is going to be the lowest value. Okay, and that is the Kelvin scale, right?
Yeah.
0 Kelvin is the absolute, means it is the lowest temperature of the universe. So it is the absolute thermodynamic scale of temperature. Okay. Absolute scale.
Okay.
So that is the Kelvin. So what is the relationship between degree Celsius and Kelvin?
Uh, Kelvin is equal to degree Celsius plus 273.
Yeah. Now sometimes we neglect that 0.15. Okay. We write just 270.
Okay.
So the lowest temperature is 0 Kelvin, which is minus 273 of the universe, right? It is the
Okay.
absolute temperature. So when you have fever, what is your body temperature?
It's higher.
Yeah. So you might have, or your mom or father may have used to measure the body temperature when you are in
Yeah,
fever, or the
thermometer.
doctor using the thermometer. Yeah. So what reading, do you know any reading? Oh, then everybody will say, oh, this is very high fever.
I think 39 degrees Celsius.
Yeah, in degrees Celsius. But actually, sometimes they say 101, 102.
Oh yeah, that's in Fahrenheit.
That's in Fahrenheit. Exactly.
100 Fahrenheit is, I think, fever.
Yeah. Okay. So
Yeah.
just do one question at what, suppose if you have 104 degree Fahrenheit, what is the body temperature in Kelvin?
In Kelvin.
In Celsius, in degrees Celsius.
1 minute.
This is 104. Fever is very high, considered to be very high.
40 degrees.
Yeah, it is 40 degrees Celsius. Exactly. So this is 40. And at what temperature, degrees Celsius and Fahrenheit, will have same values?
not sure, but I think 1 minute.
You can use this equation only.
Yeah.
So if you have degree Celsius and degree Fahrenheit are same, both are
Minus 40 degrees.
minus 40 degrees. Exactly, very good.
Minus 40.
Yeah, minus 40. The minus 40 is the temperature at which both
Okay.
Celsius scale and Fahrenheit scale reach the same temperature. Very good. So this is the temperature scale, and actually they are based on water. Okay, the melting point of water is 0 degree and the boiling point is 100 degree. Okay, so 0 degree freezing point of water is 0 degree. Okay. In degree.
Yeah.
So in degree Celsius it is 0 degree and water boils at 100 degree.
Yes.
So Celsius decided, okay, let's call the temperature at which the water freezes as 0 and the temperature at which it boils as 100, and there will be 100 divisions between these. Okay, and what will be these
Yes.
values in Fahrenheit? 0 degree Celsius
Okay.
is how much? 0 degree Celsius is how much? Yeah.
Yeah, 1 second. 17.77.
No, 0 degree Celsius is in Fahrenheit. It will be how much?
Yes. 0 degrees Celsius is 17.77.
No, no. Just check. You can put this value as
Okay.
0.
Okay, wait 1 minute. I did something wrong.
So you did all the calculation very correctly with good speed. Okay. So now tell me, degree Fahrenheit.
Yeah, 1 second. 32 degrees.
Yeah, it is 32. So everything will become 0. F minus 32 equal to 0. Okay, and that is 32. So it is the
Yeah.
freezing point of water in Fahrenheit, and what will be the boiling point of the water in Fahrenheit?
Boiling point will be 212.
212. Okay. So how many divisions are there on this scale? How many difference if you take, for example, in degree Celsius, there were 100 divisions, 0 to
80
100.
divisions.
How many?
80 divisions.
180. 180. Right?
Oh yeah,
212.
it's 2. Okay, yeah.
Yeah,
180.
yeah, 212 minus
Yeah.
32, 180 divisions. Okay. So that's how it was defined. But actually, this is the water was taken as a reference, but for Kelvin, no water. Actually, that was absolute. So Kelvin actually is the absolute scale. The scientist decided, okay, let the temperature go
Yeah.
low as much as it can. Okay, and whatever may be the lowest value is of the temperature, let's call that temperature as 0 Kelvin. So that's why it is
Okay.
called. So at 0 Kelvin, can you tell me what happens to the substance?
I'm not really sure. Maybe superconductivity.
Yeah, Maybe.
Superconductivity.
Yeah,
Some metals
those.
achieve super.
Yeah, those things may come up exactly. You have good general knowledge also, and but what about the motion of the particles? I want to know with that in that regard.
They will be solid.
They will be
Always be
solid.
solid.
Actually, what happens? The temperature is the degree of the motion of the particles, energy of the substance. Suppose if a hot body is
Yeah.
there, the particles are vibrating with a very high. They were having high vibration, high amplitude. Okay, and if the temperature decreases, the particles, their energy decreases and they vibrate very slowly. So you may keep on decreasing the temperature, the vibration motion or the motion of the particles will keep on decreasing. And there will be a certain temperature at which all the motions of the particle, whether it is translational motion or vibration motion, all stop. Okay, and that temperature is known as absolute zero temperature, zero. So it is the temperature at which
Okay.
all types of motions stop. Okay.
Okay.
Clear? That is zero temperature. Right. So this is temperature, and what about your uh, volume? Because this will be required. So what is the
Volume.
unit of volume?
Meter cube.
Yeah, that is a standard.
SI unit is meter cube.
Meter cube is how much?
In?
It is actually 1 meter. 1 meter, you know, now it will be this much from my finger.
Yeah.
Approximately
Yeah.
this. Okay. A rod of 1 meter is there for measuring. Okay, it will be 100 centimeter around this much. Okay, it will come up to this point. That is above 100 meter. Sorry, 100 centimeter or 1 meter. So if you make a
Yeah.
cube, this 1 meter tall, 1 meter wide, 1 meter broad, that will be one. And if you put water into it, that will be 1 cubic meter. 1 meter by 1 meter by 1 meter. Okay.
Yeah.
Clear? That is actually 1 cubic meter of volume. But actually, this is the SI unit, but it is too large, right? It's
Yes.
good, but because in the lab, it will be a huge, this much big, okay, or much more than that. Okay. I can't cover it in my camera. A big cube, okay, that much volume will be there. But in the lab, actually, this is a very big unit because we are not dealing with we are having small beakers and all. So this is SI unit, but in lab we use ml, okay, or liter.
1 meter cube is 1000 liters.
Yeah, 1 kl. Very good.
Yeah, 1 kiloliter.
1 kiloliter. Yeah, yeah, very good. Yeah, and 1 liter is how many ml?
1000 ml.
Yeah, 1000. And 1 ml is how many cubic centimeter? Ml is actually cubic centimeter. Either you can see it as ml or cubic centimeter. It is one and the same thing.
Okay.
So if you want to write in 1 cubic meter in ml, how many ml will be there?
10 raised to 6.
Yeah, 1 million. 1 million. Good.
Yeah.
So this is, but actually there is sometimes it is expressed in dm cube also. So what is 1 dm?
Decimeter.
Yeah.
I'm not sure. I think
Yeah.
1 decimeter cube is, I think, 1000 centiliter.
Yeah. One liter is 1 decimeter cube.
Oh, okay.
Okay. Just remember this. 1 liter is 1 dm cube, or you can decimeter is actually, or 1 liter is 1000 ml or 1000 cm cube. Okay. Or you can write it in this way. Split the centimeter into 3 and 1000 into 3. Okay.
Yeah.
So, and the 10 centimeter is 1 dm. Okay, 1 dm into 1 dm into 1 dm, so it will be dm cube.
Okay.
And this is 1 liter. So liter and dm cube are same. Sometimes in the standard books, foreign other books use dm cube. Okay, so don't get confused, right?
Okay. Okay.
Okay. And so when is your next class as per the timetable? Chemistry class?
In the school,
No, here with Learnivio.
I didn't receive any timetable yet.
Okay, okay, okay. You will receive it very quickly. Okay. So yeah. And length, what is the unit? 1 meter?
Yeah, meter.
Yeah, 1 meter equal to 100 centimeter, that all of us know. Okay.
Yes.
NDM. Okay.
Yes.
But actually these meter, centimeter, they are very large because we are studying chemistry and we are dealing with very small lengths. We need to get into
Yes.
the world of atoms and molecules. So these centimeters and meters are going to be very, very large units. Okay. So can you tell me some three basic units which are used, for example, which are very small as compared to meter?
Nanometer.
Yeah, nanometer.
And picometer and I
Angstrom.
think micrometer.
Yeah, micrometer also. Yeah. So 1 angstrom is how much? Actually, we will deal with these values because the size of the atom are in this range. So 1 angstrom is how much?
I don't know.
That is 10 to the power minus 10 meter.
Okay.
Okay. And 1 nanometer is 10 to the power minus 9 meter. Picometer is
10 to the power minus 12.
10 to the power minus 12. Yeah. And 1 micrometer is.
Okay.
So mostly we will be bothered about these units.
Okay.
So units of pressure are also there, but that we will cover in the gases. Okay. Here. So because gaseous state, we will have a lot of pressures. A lot of units are there for pressures. Okay, many more units. So basic unit, and now we need. There are 7 SI unit, international unit, you may be knowing. So
Yes.
basic units means all the other unit can be expressed in those units. Okay, and the other unit is unit for counting, that is mole. Okay, that we will cover on the next. Okay. So you have joined the full JEE syllabus, okay, for 11th. Okay, yeah. So yeah, let's do it. The mole. Actually, it is very. You may be knowing it a little bit. So let's cover it. Let's start it on the next one. Okay, You responded very well. Okay, keep your morale high like this throughout the year. Okay, so let me end today's class.